So we're going to be talking about 7-2, which is simplifying radicals, but this time with indexes greater than 2. We've done a lot with simplifying square roots, but now we're going to be simplifying cube roots and fourth roots and fifth roots. But a couple of the Vicks that you want to remember are perfect squares. Are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, because it's a number times itself that creates a perfect square. For a perfect cube, you want a number times itself times itself. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, 5 times 5 times 5 is 125, and 6 times 6 times 6, or 6 cubed, is 216. And there's other values that go beyond that, but we're going to focus on these ones for now. Same with x to the fourth. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. 4 times 4 times 4 times 4 is 264. 5 times 5 times 5 times 5 is 625. X to the fifth, same idea, but you're multiplying it 5 times. So 2 to the fifth power is 32. 3 to the fifth power is 241. We won't go too far beyond that, but those are some of the ones that you should know.
3 to the fifth is 243.
Excuse me, 243. So when simplifying cube roots, notice that you have a constant, you have a variable, and you have another variable. This is read as the cube root of 24x to the 7th times y. We're going to break these apart for each piece. So 24 gets its own cube root, x to the 7th has its own cube root, and y has its own cube root. There should be a 7 there. So when we simplify the cube root of 24, we're looking for which one of these perfect cubes, because we want a cube root to go into, or a perfect cube, to be simplified into 24. So 8 is one of our perfect cubes. So we break it apart to 8 and 3. So we're not looking for perfect squares, we're looking for perfect cubes. So this cube root of 8 is 2, and the cube root of 3 can't be simplified, so that stays as a cube root of 3. When I talk about the cube root of x to the 7th, this is really saying x times x times x times x times x times x times x. There's 7 x's. But because we need a perfect cube, we need 3 of them in order to create a perfect cube. When you take the cube root of a perfect cube, their inverses, they undo each other. So this tells you how many groups, or how many values you need per group. So if it's a cube root, we need 3 x's in order to pull one to the outside. But I have a second group that I should be able to do that with as well. So because there's 2 groups that get pulled to the outside, I'm left with an x squared cube root of x, because there's 1 left over. And I also have the cube root of y. Unfortunately, we can't take any groups out of there. So when you try to put this all together, you want to know what's on, or combine what's on the outside of the radical, and then combine what's on the inside of the radical. So this 2, this x squared, are both on the outside of the radical. The 3, the x, and the y are on the inside of the radical. So that's your final answer. For these last ones, now we're going to be multiplying radicals. So here we're multiplying fourth roots. It's treated the same way as if you were multiplying square roots. You multiply everything inside the radical. So 2 times 8 is 16. Y cubed times y is y to the 4th, because you add the powers when you're multiplying. And y squared times y to the 5th is y to the 7th. Again, you add the powers when you're multiplying with the same base. It doesn't change. But because we have different terms here, we have a constant, an x, and a y, we separate those into 3 different pieces. So the 4th root of 16 times the 4th root of x to the 4th times the 4th root of y to the 7th. Well, the 4th root of 16, what times what times what times what, gives you 16. That's 2. The 4th root and the 4th cancel each other out, so you get x. And here we would have 7 y's, but we need a group of 4. So we take a group of 4 out, which is our y, and we're left with 3 more on the inside. So when combining that all together, we have outside the radical, 2xy, and what's ever left on the inside of the radical as our final answer. For this example, we have the cube root of 80x to the 5th over 10x. The first thing you want to do is simplify as much as you can. If you can't, then we're going to discuss that next, but you always want to see, what can I simplify? So 80 divided by 10 is 8, and x to the 5th divided by x is x to the 4th. So that made it from a fraction to a non-fraction now. And we want to take these again separately. We have a constant and we have a variable. So here's my constant times my variable. The cube root of 8, what times what times what equals 8. That's 2. And here we have 4 x's. We